Hey, everybody. Happy Thanksgiving week. But first, have a wonderfully interesting chat with RTI, who develop intelligent distributed systems powering some really intriguing real world use cases. Dr. Stan Schneider, CEO at RTI, how are you?
Hi, I'm great. It's nice to see you today, Evan.
Nice to see you. And I'm really intrigued for this chat. We're going to dive into a lot of really cool technology and the history at RTI. But first, I thought we could play a quick video to kind of set the scene for the viewers who may be curious. What is an autonomous distributed intelligence system, and what's your mission at RTI? So let's watch it together, and
Okay.
I'll ask you some questions afterward.
In the next 10 years, cars will safely drive themselves. Smart networked medical devices will improve patient care. Defense systems will protect with lower cost and error. And power systems will better use renewables. In this global evolution, data will have the power to reinvent the world's infrastructure because data has transformational value. This is how RTI runs a smarter world. RTI supplies the world's #1 software framework for autonomy with over 1,800 designs. We lead the transition to intelligent real-world systems, the most important technology trend for the next decade and beyond, because it all comes back to the data. Systems that can share data in new and smarter ways have the power to open up new frontiers for sensor fusion and AI applications, for urban air mobility, for a new generation of medical robots, for safer driverless vehicle technology. And that's only the beginning. The RTI Connect software framework is ideal for powerful systems that need both AI and real-time control, because Connect implements a new concept called data-centricity to securely share information in real time, so distributed systems can work together as one. Our mission is to enable a new generation of intelligent distributed systems, boldly seeking to transform entire industries. We particularly seek applications that promote a sustainable, safe, green, and healthy planet. Together with our innovative customers, RTI runs a smarter world. To learn more, visit RTI.
Well, that is pretty compelling. Almost seems like science fiction, but this is science fact that what you guys are doing. So, congratulations on that.
Yeah.
Maybe introduce yourself and a little bit about the genesis of RTI.
I'm Stan Schneider. I'm CEO of RTI. RTI was originally actually a spin-off out of a lab at Stanford called the Aerospace Robotics Lab. We started
Mm.
our mission doing autonomous flying things. Um, that was a while back, but we took a little detour through tools, and now we're doing a distributed intelligent framework. Really think of it as infrastructure that can really connect the things that run and know about the real world, sensors and actuators like motors, things like that, to smarts, AI algorithms, like what I call functional AI. I can define that if you want to, but just smarter than it was before. So we really live at the intersection of pervasive networking and uh, artificial intelligence, and we're trying to connect them together to make things work in the real world, uh,
I
as
love it.
opposed
Well, as
to in
an
the cloud.
electrical engineer and PhD, I always love how practical electrical engineers are. Right? It's always those real world solutions. And you have a history of work in this space, leadership in the Industrial Internet Consortium, IoT Solutions World Congress. I mean, did those sort of roles influence your direction in building RTI?
Yeah, certainly. I mean, the IIC is a large consortium of industrial internet consortium. Was great. I was there. I was on the steering committee for 6 years. I was the vice chair towards the end. It was about my time there. It is a great place to pull together lots of companies to think about the future of how networking is going to change uh, these production systems out there running the world. You
Mm.
saw in the video, we do a lot of things. They all have the characteristic that they are uh, not in the cloud, but really being more intelligent. So 250 different kinds of autonomous vehicles. It's sort of hard to even describe what they are. There's flying things, underwater things, forklifts, construction vehicles, mining vehicles, ground vehicles. Lately, passenger cars on roads. Some of them autonomous, only about 5 to 10% I would call are even aiming for high level autonomy. They're just trying to get smarter than they are now. And then, we've been doing medical systems for a long time, which is an exciting world. The most exciting part of that is, everybody hears about AI helping out in medicine, mostly in things like image analysis, but we have a big customer, GE Healthcare, that's taking patient monitoring. So all the instruments you'd see in a hospital and taking that data to an intelligent algorithm to help the care teams. And we do medical
Fantastic.
robots and all sorts of stuff. Go ahead. Sorry.
No, that's fantastically interesting. I had the CMO at GE Healthcare on just last week, and he was talking about remote patient monitoring. So many use cases there. But talk about the driver, the need for this framework, this standard that you built around data distribution services. What's the big idea? Why do we need a new, do you call it middleware framework, enabler, a platform? I'm not sure of
Yeah,
the right word, but why? Why do we need this
all
for
of
these?
those
Okay.
things. It's infrastructure software. So intelligence is about data. Everybody knows that.
Mm,
You know, there's lots of AI. Everybody thinks AI is everywhere. It's not really everywhere. Almost
mm,
all AIs today run on the cloud, and at least until Chat GPT came along, the main use of AIs in the cloud is really to figure out what ads to show you. And to do that, they have to model you. All AIs have to model things.
mm,
And if you're in the cloud and you're modeling people, you have days, months, years, decades to figure out who this person is and how we can best influence or change what they do.
right.
In the real world, you can't think of data as something static you can collect. It's real-time information. It's old really quickly. So cars and planes and hospitals and power systems work on the order of milliseconds. It really
Mm,
doesn't matter where the pedestrian was 2 hours ago. It doesn't matter where the pedestrian was 2 minutes ago. It matters where the pedestrian is now. Um, and intelligence in that world is still about data, but now it's more about data flow. It's also distributed. These systems don't live in any one place. Some of them can be pretty large, and we do things like we run the Canadian air traffic control system. If you think about that, it's
wow.
distributed across the whole of the northern North America, and they're also responsible for the polar region. But you have to get data from the sensors and things to the people, and algorithms are going to make that work better. And so really it's all about getting the right data to the right place at the right time, which sounds easy, but it's really not easy. And fundamentally, the technologies that you see in the enterprise that are designed for running businesses or databases or websites just isn't designed to get data to lots of different places with what we call quality of service, with the time frame you need and the reliability and liveliness. I can explain what that means if you like, to actually be reliable enough to run something that you really care about, that might be life critical even, that has to work. And that's what we do, and it's a hard problem. And it's very different than you'd see in enterprise technologies.
Yeah, I mean, you talk about the challenges of the critical nature of your clients and their different use cases from medical to defense and air aviation and beyond. I mean, what are the is the approach for nonstop availability? I mean, what are the strategies there that you've had to employ? Because every SaaS cloud application I use is down at once a week, once a month, whatever. I don't think
Right.
that works for air traffic control, right? So what is your special sauce there?
So the fundamental thing that we do is, it's called data centricity.
Hmm.
And there's actually a diagram in the video with all these layers and
Hmm.
lines, which is true, it runs that, but it's really the wrong way to think about it. The right way to think about it is most systems are designed around, you design around the system. So you say, oh, I'm going to have a server here, I'm going to have a network
Hmm.
there, I'll have a database over here. And then later you figure out what data is going to beyond the server and networks. We sort of turn that completely upside down and think about the data first, and not just what data there is, but the quality of service, the characteristics of that data that make it work in real time. So, a database is also a data centric, but it's storage. But you can't tell a database things like this thing in the database, this part number or something will be
Mm.
guaranteed updated 100 times a second, or will be flagged if the thing that was feeding it data stops working. We can do all of that, and we can do it distributed. And so fundamentally, you can make these things work because you're designing around the data itself, and in the system, any way it can get the data to the right place at the right time, um, as long as that works, you don't the software doesn't need to understand that. So it very much simplifies software design in a way that's very difficult to do with the other kinds of technologies out there.
Yeah, it sounds revolutionary. You also facilitate kind of peer-to-peer communications without the intermediaries, the brokers and servers and things between them. Do you have any examples of how that's used in real life?
Yeah, so one of your examples, how do you keep things running? A server in the cloud is a good thing
Hmm.
because you know where it runs. At least it runs in the cloud, and it's easy to maintain, and you have people there to monitor it and update it. A server out once you have a real system that might be geographically distributed or a large system, it gets really hard to have servers because if they go down, the whole system's down, right? If you're
Mm.
trying to we also run NASA's launch control system. For they're trying to run a launch control system, and there's
Oh,
only
wow.
one server that's sort of controlling all the data, and it goes down at the wrong time. You've got a big problem. So instead of having these servers that are sort of the key things that make everything work, we actually do the same kind of functionality with a background protocol, and so it's much more robust. There's no single points of failure. You can turn off any part of the system, and it will still, obviously can't work with that part of it anymore, but the whole system isn't dependent on any one thing working.
Fantastic.
So,
No, it's really a unique approach. So is this a category you've created as well in terms of a DDS supplier and a framework for critical systems? What sets you apart from, different options out there in the market?
yeah, I mean, I'd call it real world software infrastructure, or we
Hmm.
call it smart world software
Hmm.
infrastructure. It's sort of a category. It is definitely a need out there. There's many different. There's a standard called DDS that we are compliant with. Actually, help. We rewrote the original version, helped build
Hmm.
that a lot. There's many different implementations of that, but there are other ways to do things that other technologies can work. Our technology is best for things that can't go down because there's no
Hmm.
servers.
Hmm.
Um, if it's going to be a front page news, if it stops working for a minute, we're good at that. It's not like a website that just goes off for a few minutes and people complain. If it's we run the power balancing system for the Western grid. Friends, if the power in the Western grid went down for a minute, especially since it wouldn't come back up, it'd be front page news for months, right? It's the type of thing you have to look at. But things that have to happen in milliseconds, um, systems with a lot of software, dozens or hundreds or even thousands of programmers working together on these kinds of systems. Um, that's where this technology really, really fits well.
No, fascinating. That really is a pretty new and novel, unique approach for many of us. And you also have some frameworks that enable developers to kind of integrate multiple systems and architecturally simplify application development and the logic. Is that sort of part of your suite of
Yeah,
services?
I mean, fundamentally, the infrastructure, the middleware, is a software integration environment.
Hmm.
Because it's data centric, we actually use the power of data centricity to do integration. So if you have, you know, people think data centricity is so complicated. It's really not that complicated. The way to think of it is you're writing an algorithm, and maybe you're writing some AI algorithm, or maybe you're
Hmm.
writing a sensor processor, or maybe you're just controlling a motor or something like that. Data centricity makes it look virtually, it's not true, but it looks like all the data you could ever need is already in your memory.
Mm.
Um, and so if you're a sensor, you just put it in your memory. If you're an algorithm and you have to get that sensor data, that will sort of magically appear in your memory, and you can run that sensor data and then write it to what the motor is supposed to do, and then the motor will get it and run. It really is very, uh, you know, those systems can all run independently, and that makes it much easier to integrate other kinds of software. Most of our customers actually divide their teams up by these interface specifications between different parts of the data world that they're in, rather than trying to do it around system components. And that makes it
Fantastic.
very, very easy to add in different other kinds of technologies, build large systems.
Indeed. It's quite a sandbox there you've built. Um, and you've also been recognized for kind of reducing energy use and enabling sustainability in these various industries you're in. How does that work? What's your approach there?
Yeah, well, and the biggest thing we do, we have a lot of, we estimate about 25% of the renewable energy in North America is somewhere controlled by our software.
Oh,
And
wow.
a big chunk of that is in wind turbines. We don't do a lot with solar for
Hmm.
various reasons, but wind turbines, we have some big customers, Siemens Gamesa, for instance, that are controlling the turbines. So our software is very good at distributed control. And we're really only in renewables. And why are we only in renewables? Because renewables are distributed. Most of
Mm.
the power grid runs with these, big spinning wheels. Think of it, it's not what people think of it, but most power plants are huge spinning flywheels and controlled by a very simple little analog circuit invented in the 30s that takes power out of the wheel when there's more demand and puts it back when there's less demand. That doesn't work if you got a wind turbine farm with 500 turbines, and you got solar energy that's coming and leaving. And the other big part that we're controlling is the Army Corps of Engineers hydropower portfolio, including Grand Coulee, which is the largest power plant in North America.
Oh, wow.
It's hydropower. It used to be just putting power on the grid. It's about 7 gigawatts. Grand Coulee is. They changed the mission a few years back. Instead of just putting power on the grid, it's the largest power plant in North America. It's also the fastest, measured by how quickly it can take power on and off the grid. And
Oh,
now they're
wow.
using it as, if the wind drops down, or you have a drop in solar, you can fill that in with these big hydropower plants. And it has made it much more robust and much easier to increase the penetration of renewables on the grid as a whole. So
Wonderful. Well, continuing on the renewable track, you do a lot of work in software to find vehicles, computers on wheels, basically. What's the future there for vehicle autonomy and connectivity? It looks like something you're right in the middle of.
yeah, so we're sort of known as a leader in the transition to software defined vehicles. Um, Software defined, cars today are really built out of a lot of little processors in boxes called
Hmm.
ECUs, that have lower powered computers in them, and very, very uh, single functions. So you'd have one for smart cruise control or something like that, and another one that'll raise and lower your windows. I mean, it's really that many. A modern car might have hundreds, 500 of these things, a couple hundred anyway. The software-defined control is sort of replacing that with much more powerful processors that can be doing the same functions in software and communicating over networks. And we're quite involved in enabling that transition. It has a lot of advantages. get rid of a lot of wires. You can update
Mm.
your car. Um, it will be the future of cars. It's also a huge change in the way everything is done. So it's not a fast transition. Um,
No, sadly, only 1 or 2% of the market is electric vehicles, which is still surprising given how many Teslas you see out there. But I guess it's
yeah, I think
it's the
it's
gross
more than 1 or 2% now. I have to go look at that, but it's on its way to at least the new cars. More
new
than half.
cars. Yeah,
More than half will
yeah,
be electric by the end of this decade. So that's a lot.
yeah,
Some
for
places
sure.
more than that.
Completely changing the landscape
But
there.
autonomy, I
So
think, is coming. It's going to happen. It's a long term. I've been working on autonomous systems since my PhD a long time ago. It's not a fast transition. It's a stage thing. I wrote a blog called "Autonomy is Like Happiness." It sort of went viral a year or so ago. That it really is like happiness because you can never be fully happy. There's no definition of fully happy. And there's no really definition of fully autonomous either. It really depends on what environment you're in. You can be happy at home, at work, but not at home, or at home, but not at work. And you can be autonomous in a vehicle in a, you know, highway that's controlled with no traffic lights and pedestrians and cats, and have a very hard time in that same environment. Take that same vehicle and put it in the city, it has a very hard time. So I do think you'll see it incrementally being increased. One of the reasons we're so involved in software-defined vehicles and in that transition is we have a lot of experience with taking big systems through these stages of autonomy. So we have an architecture we know can take you all the way up to level 5. I don't like the levels, but to level 5 fully autonomous, because we have many systems that are fully autonomous, not passenger road vehicles. But you need to sort of start out with something that's a little less ambitious than that, and have a software architecture that lets you evolve towards that. That's really where we're trying to enable that market.
that's fascinating. And what do you mentioned level 5 autonomy and not liking the term, but what do you think as a concept? Is that something we're going to ever reach, or is it a pipe dream for both autonomous cars and flying cars or flying
Yes.
vehicles? Do you think we'll get there in a reasonable amount of time?
Um, well, the best answer to that is yes. Uh, in some in some environments, we're already there. I mean, there's plenty of
Okay.
autonomous flying things out there, not necessarily carrying people. But there's a lot of
Hmm.
autonomous drones and other things that can
Hmm.
do a lot of functions. The best definition of autonomy I have: you're more autonomous if you can go longer without another intelligence helping you out. Um, Nothing is fully autonomous. You, Evan, aren't fully autonomous. Sometimes you need help, right? Maybe from your wife, or
Most of
maybe
the time, yes. But yes,
right,
I
right.
appreciate the
But
sentiment.
if you can go longer, if you can spend the whole day, a new employee at work might need to have, uh, higher level input every 20 minutes or something. But once you get to be a professional and you got a lot of experience, you might be able to go weeks without any uh, external input. Um, Cars are like that too. It depends on the environment. It really gets more autonomous as they can do more and more complex things without help. And I definitely think we're going to get there. Um, I think we're very close to getting there in some road applications. Everybody wants to talk about autonomous cars, which is fair. I mean, we do a lot of that too. I actually just found out yesterday I can mention Motional as one of our customers. So the
Mm.
autonomous vehicles running around Las Vegas are running our software. But
Oh,
those are
fantastic.
high level autonomy. Um, there are many, many other customers we have that are building vehicles that aren't targeting level 4, level 5 autonomy. They're just targeting architecture that they can evolve over the next 10, 20, 30 years
Mm.
to get there. And I think you're going to see that as an evolutionary process, not a revolutionary process, but more functional every year, and definitely getting more safe. I started my
That's
career, by the way, as a safety researcher in automotive, crashing cars for a living, or parts
okay.
of cars,
Well,
research a lot of
that must have
engineering.
been fun. Yeah, it sounds
It
like a
was fun.
cool
I have
job.
a lot of faith in the inability of humans to ever be really good safety systems. I think that autonomous vehicles, while they aren't perfectly safe and probably never will be perfectly safe, the safety problem, all you really have to do is be better than humans, and that bar isn't as high as you might think in a lot of environments, because humans, they drink too much, they drive when they're tired, they drive when they're
Mm,
angry, they make bad decisions, that they get distracted, that an autonomous system never will. So autonomous systems will make mistakes humans would never make, and everybody focuses on that. How could it be that stupid? But humans make mistakes every day. Several people have died in the United States during this conversation because people make
mm.
mistakes, and I think that that level of safety is not as high a bar as uh, it should, as it as people think it is. I do think accepting risk is very hard for people when they can't control it. Just like flying an airplane still scares people, and it's incredibly safe to fly on an airplane. It still
Yeah,
scares
well
people.
said. And
You don't have
talk
the
about
control.
autonomous systems from takeoff to landing now. It's pretty autonomous these days. Your expertise is wonderful. It's great to chat with you. I love your sort of connection to academia. How do you keep that connection? You seem to have a commitment to emerging technologies and working with researchers and academia. That must be part of your drive as well.
Yes, so we have an active research department at
Hmm.
RTI. We do a lot of research on various things. It's a big part of our culture and history to be
Hmm.
tied in with the research community and build. Uh, we're actually very good at commercializing research. We got an award at one point for being in the top 1% in the country of
Oh
commercializing
wow.
research. Because one of the things from my Stanford background, I don't think that most researchers are very good at staying in touch with what's actually being built. And they go off and they work on something for 3 years and they come up with something really good. And now it's just too hard to get it into the product. And
Mm.
so it takes another 3 years to try and do that. And it's a never ending chase to get the research into the real world. It's something that we work very hard on from day one to make sure that the research is always working with the product development teams and product management. Um, it's an
Fantastic.
important
Well,
thing to do.
congratulations on all the success, and we'll be following and rooting for you. Traditional Thanksgiving tomorrow with turkey and all the trimmings, or
Yeah, yeah, I'm
do
up
you go
here. We
rogue?
got a couple of my kids, not all of them, but we're up here and we're going to have a great turkey, a spatchcock turkey.
Fantastic. Now, when you're talking to friends
Not
and
really
family,
traditional. It's a new turkey. It's a new turkey design.
there's always something new under the sun. So, when you're talking to friends and family, I assume they're not all electrical engineers. So, how do you describe what you do to the lay people in your life? How do you,
We run a
what's
smarter
your,
world. We
oh,
connect
there we go.
all of
Okay.
the things that run the world, which is really sensors that tell you what the world's doing, and actuators that can change the world to intelligent algorithms reliably, fast enough to make it work.
Oh,
That's what we do.
that's
And
very
across
that's a fun way to
2,000
describe it.
applications and dozens of different industries. The most exciting ones to me, anyway, are medical, connecting with AI, some of the more intelligent, lower costs and safer defense systems. The renewable energy is great. Autonomous vehicles, I think, is a long journey, but one that I've been on for a long time, and I'm sure we'll get there. There's no question whether we'll ever have autonomous vehicles. Um, you know, you said in a reasonable time frame. That's the hard part.
Yes, what is reasonable? Well, considering we probably should run here and let the viewers get on with Thanksgiving week. But thanks so much for sharing your unique insights and experience. I really enjoyed it. I think a lot of my techie geeky audience really enjoyed the chat. And thank you, Stan. And reach out, folks, to RTI with any questions or comments you might have.
Okay, thank you. It's great to
Thank you,
talk with
Stan.
you, and
Take care.
um, Yeah,